We're going to go ahead and look at lesson 3.2, which is about exponential functions. There'll be two parts of this lesson. Here we will just look at the idea of exponential functions, and then we'll go ahead and look at an example of exponential functions with compound interest. So, exponential function is a function in the form f of x equals c times a to the x, where c and a and x are all real numbers. A is greater than 0. This will, if it was negative, then we would end up with some really wacky graphs and imaginary numbers. And then we don't let a equal 1 because 1 to any power is still just 1. So that's not an exponential function. That would just be a linear function. We notice here if a is between 0 and 1, so a fraction between 0 and 1, then f of x is a decay function. It decreases as x increases. And if a, which is the base, is greater than 1, then it's a growth function and it will increase. So let's go ahead and look at an example of each of those. Whenever we come across a new function, we can go ahead and plug in some values and see what happens. So we're going to do that here with these two functions. Notice in the first one, a is greater than 1, so it will be exponential growth. And in g of x, the second one, a is less than or between 0 and 1, so it will be exponential decay. So let's plug in some values. I'm actually going to start at 3. Usually I start in the negatives and work my way up. We're going to work our way down this time, just so you can kind of get started at least. So 2 cubed is 8. So we're putting 3 in for x. 2 cubed is 8. So when we have 3, when x is 3, y is 8. Putting 2 in for x, that's 2 squared, which is 4. So 2, 4. Putting 1 in for x, 2 to the first is just 2. 0, 2 to the 0 is 1. And now we put in negatives. So when we put in negatives, this is 2 to the negative first. Well, we know that means when we have a negative exponent, that power moves to the denominator and it's 2 to the first, which is just 1/2. So when x is negative 1, we get 1/2. When x is negative 2, that's going to be 1 over 2 squared, which is 1/4. When we put in a negative 3, that's going to be 1/8. And no matter what negative we put in, it will keep getting smaller, but it will not ever reach 0. And so our graph is going to look something like this. Down here at the x-axis, I'm going to put a dashed line here. This indicates the graph will keep getting closer and closer to the x-axis, which is y equals 0, but it won't ever reach it. And now looking at g equals 1/2 to the x. So let's do the same thing. We'll start with 3, 2, 1, 0, negative 1, negative 2, and negative 3. 1/2 to the third. That is 1/8. So at 3, we're at 1/8. Pretty small here. 2, 1/2 squared is going to be 1/4. So when we're at 2, we're at a quarter. 1/2 to the first is just 1/2. So that's here at 1/2. 0, anything to the 0 power is 1. 1/2 to the negative 1 power. Negatives Actually can indicate reciprocals. So this is equal to 2. So when we had -1, we're at 2. -2. Negative exponent means we want the reciprocal. So the reciprocal of 1/2 is 2. 2 squared is 4. And when we put in -3, we get 8. And we see our graph comes down left to right. It decreases. The x-axis will once again be a horizontal asymptote. Actually, we haven't mentioned that term yet. So this x-axis won't ever be, the graph won't ever reach it. So an asymptote is a line that the graph approaches but never reaches. We will be talking about vertical asymptotes later, which have a little bit different, and we'll mention some other things about horizontal asymptotes, but this is our first time seeing those. All right, the number e. Number e, it's an irrational number that appears in many mathematical and scientific notations or applications. It's about 2.7. It is irrational, so it keeps going and going and going, but it's about 2.7. And it's used with exponents quite a bit. So the natural exponential function, f of x equals e to the x, where x is a real number, that's called the natural exponential function using that natural number e. So we'll take a look at this function. I'm going to go ahead and bring up a calculator here. Let's put it on this side. And there's this button on your calculator. It's down here with the ln. So e to the -3, we're just going to plug these in. We get 0.049, so about 0.05. Pretty small number there. -2. So e to the -2 is 0.14. E to the -1 is 0.37. E to the 0, anything to the 0 power is 1. E to the first, so here's actually what e equals, 2.718281828. Looks like there might be a pattern. There is not, though. There's not a repeating string of numbers there. So we're at 2.7. 2.72. E squared, 7.39. And e cubed is 20.09. So we can graph this -3. -3, we're pretty low, almost on the x-axis. -2, we're barely up from there. -1 is about a third. And then we're at 0, 1. 1, 2.72. 2 is 7.39. It's about there. And then we can graph this function. It is an exponential growth. It's going up left to right, and it looks like that. Now, our last example here has to do with kind of transforming this function or an exponential function. And what we're going to notice is that we'll expand this a little bit. The -3 out here is going to move a function up or down. This one's going to be moved down 3 units. The +2 is going to move our function to the left. And then the 1/2 is going to make it less steep. So what I'm going to do to start with is just graph y equals 3 to the x. So y equals 3 to the x. You can make a little table. We're actually not going to use as many numbers this time because we don't need them. So when x is 2, y is 9. And again, we are just graphing this, not with all the changes in it. 3 to the first is 1. 3 to the, 3 to the first is 3. Sorry. 3 to the 0 power is 1. 3 to the negative 1 is 1/3. And 3 to the negative 2 is 1/9. So here's a graph of this bluish function here. Negative 2 is at 1/9. Negative 1 is at 1/3. 0, 1. 1, 3, and 2, 9. So there's that function. All right, let's take a look at what happens with these transformations here. It's going to be moved up 3, left 2, and the tricky part is going to be this 1/2. So the point that was normally at 0, 1 would move down 3 and left 2. So it would be somewhere about right here. But then let's see what happens with this 1/2. So I don't know why I had those labeled like that. So let's go ahead and plug some of these in here to see what happens. So we have 0.5 times 3 to the, let's plug in 2. So 2 plus 2 is, I'll actually just put all the work in here. I know some of it we can just do in our head. So I'm putting in this whole function. That's 37.5. So that is way off our graph. So let's, well, we can write in here 37.5. And that's, so it's large because we added 2 here. So that grows a lot quicker. So let's put in 1. So we actually can put in that same entry. You hit the second button and then the enter button. It puts in the same entry, but we just want to change this to A1. So that's 10.5. So at 1, we're at 10.5, which we can fit on here. So we'll do that second and then entry again. We're going to change this to a 0. Now we're at 1.5. So we had x is 0, y is 1.5. That's right there. Put in that same function again. Oops, that's not what we wanted. And change this to a -1. And we get basically -3. So when x is -1, y is -3. Actually, that's, realized that. Put in the wrong thing there. So we need to put negative, but we need to insert the 1 there. There we go. -1.5. That makes more sense. And then we'll put in -2. And that's -2.5. And so we know there's going to be, so it's going to look like this. what I'm going to do now is I'm going to put in a pretty large negative number. So I'm going to do the same thing. I'll tell you why here in a minute. I'm going to put -9. And we're going to see this is getting closer and closer to -3, but it doesn't ever reach -3. So -1. So this is about -2. And then -3 would be here. And then so we could put a dashed line here at -3 and then graph that. So there's the graph of 1/2 3 to the x plus 2 minus 3.